Hello and welcome. Thank you for tuning into my channel. My name is Dr. Bindesh Nunia. I've done my Ph.D. in civil engineering. So today I'll start the lecture series of structure dynamics with MATLAB. In this module, we'll try to solve structure dynamics and vibration related problems using MATLAB. So after this course, you'll be able to simulate structure dynamics problems using MATLAB, and you'll be able to make such codes and run those codes. So before going to this main content, that is the structure dynamics problems and all, like spring mass damper, etc. Before going there, I'd like to tell you that this will be a tutorial course for MATLAB as well. So after, even if you are not associated with structure dynamics problems, or let's say if you just want to learn MATLAB for any other work, this will be helpful for that also. So if you want to learn MATLAB, simply follow whatever I am doing. You don't need to understand. If you are not from civil engineering, or you are not interested in structure dynamics problems, then what you can do, you can simply just mug up the theories and just practice the MATLAB code. So eventually you learn MATLAB. So if you just want to learn MATLAB, this will also be helpful for you. This will be useful for you. And if you want to learn both MATLAB as well as theory, then don't worry, I'll explain the theory as well as MATLAB code. So if you need any help, then you can contact me through my contact details. And so let us start. So before starting to the main content, what I'll do, I'll give a brief idea about the MATLAB, those who are complete beginner, absolute beginner, and those who are new, those who are aware of MATLAB. They can just bear with me for a few minutes so that I can give a brief introduction. So MATLAB stands for Matrix Laboratory. So here all the operations that we carry out is basically matrix. So matrix multiplication. Now you just have to remember one thing: matrix multiplication rule. So let's say if I have a matrix its size is n by n and n by m, and I have another matrix its size is p by q. Now this one, n represents row, m represents column, p represents row, and q represents column. Okay, sorry, column. Now these are rows, these are called rows, and vertical elements are called columns. Now for a matrix, let's say this matrix is A and this matrix is B. Now A cross B matrix multiplication will only be possible when your M is equal to P. That means this will be true only when M is equal to P. If M is not equal to P, then this multiplication is not possible. Okay, so make sure always you will have to keep this in your mind while working in MATLAB. So if I multiply A cross B, what will be the new size of my matrix? N cross Q. This N and this Q. Now let me give you an example. Let us take an example of a matrix 2, 3, 5, 6. This is a matrix A, and let us take another matrix 1, 2, 3, 2, and this is matrix B. Now size of matrix, how many rows? One row. This is called one row, this is called two row. So two row. First we'll write row and column, then we have one column, two column. So two columns. Similarly, size of matrix is 2 by 2. So A cross B will be, if I multiply these two, 2, 3, 5, 6 and 1, 2, 3, 2. Okay, so always matrix multiplication occurs in row and column. So this row will get multiplied with this column, then again this row will be multiplied to this column. So if I multiply this row, 2 into 1 plus 3 into 3, so this will give me my first element. Next is my, again this row, this column, 2 into 2 plus 3 into 2, then again second row, 5 into 1 plus 6 into 3, then again 6 into 5 into 2, 5 into 2 into plus 6 into 2, always row column multiplication. So this is how you got. Now the size of this matrix was 2 by 2. So if you see, these two are same. If I denote it as n m p q, so likewise as I have said here, m equal to p, so these 2 equal to 2. Now the size of the matrix that we have got is 2 by 2. So this is how it works. Now let us do the same operation in MATLAB. So we'll learn like this first class, because eventually my goal is to teach you MATLAB, and also structure dynamics will use the structure dynamics to teach you MATLAB. So for both kind of people who want to learn structure dynamics, who want to learn MATLAB, for both of them it will be helpful. Now here itself you can operate, but in the MATLAB, here this is the I would say whatever operation you will be doing, it will be visible over here if you do not put semicolon, and this is called command window. Now I'll open the editor, edit. It's simply write edit and press enter, so it will open editor. So this is the path where files are saving. Now you need to always keep a habit to change the path. So I'll go to desktop, I'll create a new folder, I'll name it as MATLAB structure dynamics tut. Okay, so my folder has been created. I'll select this, I'll click select folder. So now see, my path has been changed. Now everything will be available in this folder. Now first of all I'll have to save the MATLAB code. Let's say I'll name it as tut1. Sorry, you cannot give space etc. You can write tut1. You cannot give space and save it. So tut1 has been saved. Now you can write your code over here and you can execute, and those will be visible over here. Now this one is the script or whatever data you have in your folder, that is this folder, the folder that I have created, where it is, somewhere here I have created, yeah. So whatever data I have, this will be visible over here in this current folder. Let's say if you are not getting this type of visualization, simply right click on these things, right click on the top, and you'll get all the options. Okay, let's say I want to close or I want to visualize. This is called dock and undock. Undock means it will be like this. See, I don't have that window over here, it is separated, and I have undocked now. Now I'll dock it. That means everything will be visible. So it becomes easier. Like you can see whatever file you have in your folder and all the variables that you will be using over here. Variables means here, if you see, I have assigned matrix A something, matrix B something. So all those things will be visible. What is A? What value you have assigned to for A? What value you have assigned for B? So everything will be visible over here. And this is called editor. So here this button is used for running the code. Whatever code you will be running over, writing over here, you can run that code using this, or you can select it and right click it to execute the command. I'll show those things, don't worry. And sometimes there are one more thing I just want to show you. Yes, these things, sometimes these things are not configured as it is shown in my PC. So you can go to layout and you can switch on, switch off. See, if I switch off workspace, it is deleted. If I switch off current folder, it will be deleted. You may have configuration like this, so you can switch on all those from here, and you can drag or drop anywhere. Let's say if you want your variables to be here, you can work like this. Okay, so it doesn't matter, you can just drag and shift. Now let us start. So I have assigned matrix A. I'll write A equal to, so always write the matrix in third bracket. What is the matrix I have written over here? It is 2 3 5 6. So 2 space 3, and now I need to go to the second column. Second row. First row I have written, now I will go to second row. So to go to second row, what I will do, I'll simply use a semicolon. Okay, if I use semicolon, what is second row? 5 6. So 5 space 6. Now this will give me a 2 by 2 matrix. If I execute it, see, it is visible over here. And as I have said, A, I have assigned this variable, it is visible over here. Now if you double click this, it will be visible in terms of matrix over here. Okay, now see, I have executed it and it is visible over here. Now let's say you have n number of, like you are writing code, like you have 5,000 or 6,000 coding line. If you are not putting a semicolon at the end, everything will be displayed over here. And displaying a small matrix is not a big problem, but let's say if you have a big code, displaying everything takes lots of memory. So we use a semicolon to suppress the response. See, I have executed right now. It is showing me just execution, but it is not showing me this value. Okay, I'll clear the screen. I'll clear the screen. To clear this screen, you just have to write CLC. So if I just use CLC, it will clear my screen. Now see, I'm evaluating, or I can run it. I'm running this, but nothing is visible over here, but it is getting executed. But if I remove this column, semicolon, if I run it, it will be visible. Okay, so always keep a habit of putting semicolon. Now you can write matrix B in the next line, or you can continue in this line giving a semicolon itself. Similarly, give third bracket, close the line. Now what is the B matrix we have written? 1 2 3 2. So 1 space 2 semicolon 3 space 2. That's the matrix we have written, I guess. Yes. So now if I execute this, you will see B will be available here, but it will not be visible over here because I have put a semicolon over here. So see, it is just the execution it is showing. If I run it, nothing will be shown over here. So A, B both are here. Now I can operate. You can just press enter and keep it in second line, no problem. And I can operate. Now I want to get a C matrix. C will be A star B. Now if I execute, I am getting A star B is 11, 10, 23, 22. Now how 11? See, this is 9 plus 2, 11. So likewise we have got a matrix. And next, let's say if you want what is called okay, now as I have said, I'll delete this example and let us take another example. Here now let's say a matrix A equal to 2, 3, 5, 6 and a matrix B equal to size of this matrix is 2 by 2 and 1, 3. This is another matrix. Okay, so size of this matrix is one row and 2 column. So can you tell me whether multiplication is possible or not? If you again go with the same rule, n into m p cross q. So again I am telling those who know all these things about MATLAB, they can skip this lecture, because I just want to start from the beginning for all those who are absolute beginners in MATLAB. So I just want to give them a basic idea about this operation. So now here m is not equal to p, so A cross B is not possible. Okay, this is not possible. Now if I what I can do, A cross B is not, but A into B transpose is possible. Now how? B transpose will be, row will become column 1, 3, isn't it? It will become 2 by 1. Now B transpose has a size 2 by 1 and A has a size of 2 by 2. So now the size of what will be the size of A into B transpose? It will be, these two are same, so this will get cancelled out. Size of this will be 2 into 1. Now let us check. A is 2, 5, 3, 6. Again I'll edit it, 2, 5, 3, 6, and B I have written 1, 3. B is my 1, 3. Now if you see, if I try to execute this, I'll try to run this, it will give me an error. See, incorrect dimension for matrix multiplication, check that numbers column in first matrix matches the numbers of rows in the second matrix. So this will give you the error code that the size of matrix A and B is not correct for multiplication. Now if I make B transpose, now how to make B transpose? Simply put a what is called apostrophe that we usually use, this sign. I do not remember what is the name of usually we use for apostrophe, as let's say you want to write somebody's name like John's father. So how you write? John apostrophe as John's father, isn't it? So that sign you just have to use over here. Now if you see, this multiplication is possible, so it becomes C. Now C has become a matrix which has having 1 column and 2 row. So that's how, 1 column, 2 row and 1 column. So this is a basic idea. Remaining you just need these many this is sufficient for your basic idea, and don't worry about that. We'll proceed when we start learning other things. You will be able to learn MATLAB automatically, so you should not be worried about it. Okay, now one more thing, if you need some things inverse, okay, matrix inverse. So let's say I need A inverse. So let's say C will be A inverse. Okay, so you just have to find out A inverse manually. If you want to find out A inverse manually, that is also okay. But if you just simply write A inverse, that will give you the inverse value of A. Okay, so what I'll do, I'll simply write INV, give a bracket and enter. Make sure these are case sensitive. See, I have written capital letter A. If I write a small letter A, it will not take the variable. Software will give you a simple error. See, it is undefined function or variable. That is, it doesn't know A, but it knows capital A. If I write capital A, you see, it will give you. So this is how you can calculate inverse of A. Okay, or let's say if you want to find out what happens, let us check what happens with this. It is giving the same value. Okay, now what is this? This is power a to the power -1. That's how we write, right? A inverse, A inverse. So in this is 1, this is 1, A inverse. Now this is how we write in manually, and in MATLAB what you write, A. Whenever you want to give power to any letter, any variable, simply use this sign and write -1 is the power. Let's say A square. How you will write in MATLAB? You will write A power 2. So we will take the power. That's all. So these are basic things. I don't think you need anything else apart from this. This will be sufficient for your beginner to proceed. Remaining thing we'll learn when we proceed with the with our problems, etc. So we'll be able to easily proceed. One more thing, I just want to give you an idea. Let us do a simple, what is called simple test of okay, sorry, I should not have deleted all this. I should not have deleted all this. I must keep this. Sorry. I just want to keep this as record, so that if I give you this code, if you need this code, then I can give it and it will be helpful for you to learn. I'll keep a record of all this. So if I keep a record, it becomes easier. So I'm keeping a record of all this. Now one thing also I have forgotten to mention, that CLC will clear this screen. If I execute CLC, if I simply select this and execute, it will clear the screen, but these variables are not getting cleared. If you want to delete all variables, you can simply write clear all. So if I simply select this, it will clear all the variables. So always I use these things. Let's say you want to assign a new variable all the time, so I utilize these two things. And one more thing, okay, now let us try to do to find the sum of first and natural numbers. To find the sum of first 10 NATURL natural. Now this is a comment, okay, so you cannot execute it. Okay, so what you can do, to write a comment, you just have to add percentage sign. So these are comments, so this will not be considered as coding code, and it will just be used as a comment. Now let's say we need the sum of first 10 natural numbers. So first number n equal to 0, let us write, okay, uh, what we can do is I'll write for I is a variable, I equal to 1 to 10, and I'll end. So see, I have written a for loop and I have ended it. Now for I equal to 1 to 10, okay, that means I will vary 1 2 3 4. So for first time the code will run and it will take the value I equal to 1. Again, this is a loop, okay. So loop means what? Whenever I am writing for, whenever I am using for, that what happens, for I is a variable, you can write your name. Let's say my name is Bindesh. So Bindesh equal to 1 to 10. This colon is used to represent 1 to 10 means, and I am ending the loop. So this is one loop. So what will happen? Software will come over here and it will see that okay, for loop is there. That means first it will take 1. So first execution it will take Bindesh equal to 1. If I write Bindesh over here, then it will display me that one. So instead of I, if I write my name Bindesh, so, and I want my software to display what is the first loop. So I can use pause button over here. So if you simply click over here, it will give you a pause button. Now if you try to run, see my command has started from here. It has checked first line, second line, third line, fourth line. These are empty, so it has checked, it has got nothing. Now my command is here. If you see the error line, and my command is here, it is taking Bindesh. It has found that it has to go from 1 to 10. So first it will take, now you will just go increase one step. So next line is 8. Why? Because my 7th line is there is no 7 line. So what I will do, I will not keep any empty line. I will delete all empty line. Doesn't matter, even if you keep, no problem. I have simply added a pause over here. I have run the code. It is standing over here. Now here it has taken Bindesh equal to 1. Now what it will display? 1. See, Bindesh equal to 1. Again, now it is at the end of the code. Again it will go for here. Again it will take the, because it know that for loop it has to run until it has reached 10. Now what will it will take? Bindesh equal to, just check, 2. Why? Because for when I write for 1 to 10, that means it is written 1 comma 2 comma 3 comma 4 comma dot 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 10. So every time it will run this loop, it will take, first it will take 1, then it will take 2, then it will take 3, then it will take 4. So whatever variable here previously I have given 1, you can write your name or A or B, any variable. So these will be getting one by one values will be assigned. See here it is changing, okay. So this operation is simply used many ways to execute the solution. Now we need to find the sum of first 10 natural numbers, okay. So I'll again make it I. Now sum of first 10 natural numbers, that means 1 plus 2 plus 3 plus 5, 4 plus 5, isn't it? So what I'll do is you can simply execute it. I equal to I plus 1, okay, and this will give you So what happens? Let's say, let us check what is happening with I plus 1. Again I have quit the program. I'll run over here. It has now this I value is, if you simply place your cursor, you can see what is I is 1. So 1 plus 1, new I will be 2. Now this is at the end of the code. So here this I has become 2 and this was already 1. So this one initially it was 1, so 1 plus 1 it has become 2. Now again it will go over here. Now here if you see, again I equal to 2 and we have already assigned I equal to 2. Now what will happen? I is my 3. So it has already performed. So if you see what happens, 1 plus 2 plus 3 plus 4 plus 5 plus dot 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 10, isn't it? So 1 plus 2 is my 3. Okay, in next execution, here if I simply continue, it has become 4. Again it has become 5. So I is simply increasing one by one, 1 2 3 4 5. Likewise, that means here at the end, here I has become 5. Again if I come at the go for the next loop, now my I is 5 and this will become 6. So this is simply increasing. Now to make the sum, I'll write sum equal to sum plus I. Now what is happening here? Sum, this will give me my total value. Every time it comes, like first will be summing 1 with 2, then 2 with 3, then 3 continuously. Whatever I value, we just have to keep adding. So initially I will define my sum equal to 0. Initially my sum was 0. Now if you see, if I suppress this and again I try to run it, so my sum is 1. Why? Because sum was initially I have defined 0. When it come to the loop, it taken sum equal to 0 and I equal to 1. 0 plus 1 equal to 1. Next it will be, here sum was 1, I was 2, 2 plus 1 equal to 3. Now it will be 6. Why? Because this 2 plus 1 equal to 3, then 3 plus 3 equal to 4, then 4 will be added up. So likewise, if I simply continue, it has given me the complete sum. So now at the end you should display what is sum. So suppress this and remove the pause button and display what is the sum. So it has displayed you the total sum. Now I am just simply giving, even if you don't use this one I have just give. Sometimes it is required to run, it is required sometimes. Okay, let's say if you want some step to be not one by one, but it will take let's say if I suppress this and if I resume it, I'll show you what happens, why this logic is required. Now see, here here I is 1, but here this I will become, or let's say yes, this I will become 3. Why? Initially it was 1, next it has become 3. So sometimes we need to run it 10 times, but we want to take like 1 3 5 7 like that. So if I again run it, now the I is 2, but here it will take 4. So when you don't need 1 2 3 4 5 6 continuously, you need 1 3 5 like that. In that case you can utilize this logic. Okay, so for the time being I'll keep it like this, and again I'll keep a record of this. Okay. Next, so I guess this much is sufficient. I can directly go to the my first problem of structure dynamics. Okay, okay, we'll see the plotting etc. when we do the problem. Okay, we'll not go to the problem each and every small tutorial, because our basic aim is to teach you the structure dynamics. And what I'll do is, when you perform such structure dynamics and when you will be plotting the response, there you will learn how to plot. So to learn the MATLAB, you should not just start practicing anything randomly. To learn the MATLAB better, you take any problem and try to solve it. So eventually you will learn the complete MATLAB. Okay, now let us take the problem of spring mass damper system. So we'll have this spring, and then just forgive my drawing. Why it's not coming in? So again, and this will be my, again let us give some space, and okay, and this is my spring, and next is, this is my ground, it is connected to a ground. Okay, this is my ground. So this is M, this is K, this is C. Okay, so this is a mass spring and damping system. Now we'll try to solve this system. We'll try to make a MATLAB code of this system. Okay, and we'll see what happens. So this is my basic I would say model that will try to solve for structure. If you want to understand structure dynamics, you must have to know how to solve this problem. This is the basic building block. This is the basic building block of all the different structures which is subject to earthquake or any type of vibration or any type of dynamic force. Even if there is a building of multi-story building and it is subjected to earthquake, that is also governed by these basic system. Or even if there is a machine on the building and it is vibrating, everything is related to this problem. So all this is the basic of structure dynamics, basic building block of structure dynamics. If you do not understand this problem, you won't be able to understand any other problem of structure dynamics. So first, we'll not keep any damping. We'll simply keep these. We'll delete this damping. There is no damping. Let's say there is no damping. Now what is damping? Let's say whenever if there is no damping, the system will keep vibrating continuously. Damping is nothing but I would say a force that slowly, depending upon the percentage of damping or depending upon the amount of damping the system has, it reduces the force which is acting on the system, or not reduces the force, it reduces the response of the system. Let's say if there is a pendulum, and if there is a pendulum, and what you do is if there is a pendulum and you have pulled the pendulum somewhere here and you have left it, so what it will do, it will swing like this, like this, like this, and initially it will after some time the response will die down. Why it is dying down? This is due to the damping force. Okay, this is due to the damping in the structure, which is causing the response to decrease slowly. Okay, so it reduces the response of the model, and it always acts opposite to the motion. If object is if the pendulum is moving like this, the damping force will act opposite to it to counter the response. If there is no damping, what will happen? If there is no damping, that means system will keep on vibrating. System will keep on vibrating with same amplitude. Now what is amplitude? This value, like how much the curve is going up. It is going up this much, that means its amplitude is higher than this. If it is going like this, it is going like this, that means amplitude of this curve is higher than this. So the y-axis represents the amplitude. A-M-P-L-I-T-U-D. It could be anything. The velocity, displacement, acceleration, it could be anything. So that's how basically the amplitude means. And what is frequency? You should know all this because you'll be dealing with all these problems. So I'm just give you an idea. The frequency is the number of cycles obtained in 1 second. Let's say if you have a pendulum and it is moving, you have pulled this pendulum over here and you have left it. So what will happen? It will swing back and forth, back and forth, back and forth. Okay, so what is frequency? The pendulum starts from here, it has gone up to this point, and again it has come to its original position. Now the time required, you just note it down, whatever time required, and in 1 second how many cycles it is performing. Like in 1 second how many times it is coming back to its original position. Okay, let's say it has first 2 1 2 3 4 cycles it has performed in 1 second. You have moved this at such a faster rate that in 1 second it has 4 times it has come to its original position. That means it has performed 4 cycles. First cycle, second cycle, third cycle, and fourth cycle. I don't have space, that's why I am drawing it. If I have to draw it properly, I'll delete this. I'll mark the 4 cycles. 4 cycles in 1 second. First, second, third, and fourth in 1 second. The time period is 1 second. So always remember, whenever we talk about the frequency, we'll note down that how many cycles are performed in 1 second. That's why unit of frequency is cycles per seconds. Okay, so in 1 second how many cycles are performed, that is called frequency. This is called cyclic frequency, and there are also angular frequency. Let's say the watch that you have. So let's say this is a needle, or I would say arrow. So if it is rotating like this, and it takes it rotates 1 times in 1 second, then again I am saying the same definition, that how many times it reaches to its original position in 1 second. So it has started from here, and again it has come back to its original position like this in 1 second. Then the frequency will be, this is angular frequency, so we measure it in radian. So this is for radian per second. In 1 second, how much angle it has traveled. So how much angle it has traveled? 360 degree. So this is called angular frequency. Okay. So it is similar to that. Here also we are measuring in second. So always here we are seeing that how much time is required to come to its original position. Here also we are seeing how much time is required to, in 1 second, how many times it has reached to its original position. Here also we are checking the same thing, that in 1 second how many times it has come to its original position by moving like this. So let's say you have started your journey from your home, okay, and you have gone to your college. So now in 1 second, let's say you have so high speed that in 1 second you are running in a bullet train, and let's say the distance of your home to college is 1 meter. So let's say you have started from your home, you have gone to your college, and again you have come back to your home, again you have gone to your college. So let's say in 1 second you have done this process twice. That means you have 2 times you have come to your home. First you have started your journey from home, then you have gone to college, then again you have come to your original position, again you have gone to your college, and again you have come to your original position. So how many times you have come to your original position? Twice, isn't it? Because initial one will not be taken care of that. Now what do I mean by that? Again, to understand the frequency, best example is you have started your journey from your home, and this is your college. So in 1 second, first you have started from your home, you have gone to your college, and again you have come back to your home. So this is 1. Again you have started your journey gone to your college, again you have come back to your home. This is 2. So in 1 second, let's say you have done this process in 1 second. So what is your frequency? 2 cycles per second. And in angular frequency it becomes radian per second. So we'll see the formula, etc., how to calculate. This is the basic things that I wanted to explain you. Okay. So this is a mass spring system. We have not used the damper. Damper we'll check later. So as I said, the damping force usually acts opposite to the motion. Okay, it acts opposite to the motion. Now as we do not have any damping force, so what we will do, system will keep on vibrating. System will keep on vibrating for an infinite time. Now here we'll solve this problem in MATLAB also, but I just want to give the theory along with the MATLAB code. That's why I'm going through it. So this is the vertical vibration. The degree of freedom of this mass is upward. Okay, degree of freedom means in which direction it is allowed to move. Okay, so it is vibrating like this, vibrating up and down, up and down. Okay. No, don't copy the 3 idiots up and down. Somehow it is okay. So this is its degree of freedom. Now when this mass tries to go up, let's say you have pulled the mass at a force P of t. P of t means P is the force and T is the variable force at a time t. So what will happen? This spring will try to pull it back. So the force will be K into U. Whatever displacement due to this force is occurring, let's say if this displacement is U, then the force, restoring force induced by this spring will be K into U. And if there is a damping, if there is a damping also, then what will be the force? It will be C into U dot. c into u dot. U dot is the velocity, that is derivative of u. So if you derive with respect to if you derive this derivative of u, will give me the velocity. U is my displacement. Okay, so du dx is my u dot, is my du dx. Sorry, du dt. Du dt will give me the u dot is my velocity. So if you solve this system of equation, and due to this, as it is moving in this up, as it is moving up, now what will the equation if I try to write? Now gravity is also acting on this model, right? If gravity is acting, that means mass, we have mass, so due to the gravity we'll have another force mg acting downward, and as this model we are pulling it up on upward side, so there will be a, due to Newton's, see, mass into acceleration, there will be a force which is called Newton's law. From Newton's law we know that force equal to mass into acceleration. So here acceleration will denote it by u double dot. U double dot is my d square u d t square. Avoid my writing. So if you check any general book, you will get these derivations. That's why I am not going deep into it. I am just explaining you the concept. Okay, so we are pulling it on this side, so this force will act opposite to the motion of the body, which is nothing but my m u double dot. If you write the equilibrium equation, it has become m u double dot plus c u dot plus k u equal to p of t. This is basic equation of motion. Now whenever a body moves like this force acts always opposite to it, and it depends on mass and acceleration. Now this is the main force which plays in structure dynamics. In structure dynamics, if you remove this damping force, then this becomes a static force, static solution, k into u equal to p. This is the static equation of motion. Whenever mass comes into play, it becomes dynamic. There is an additional force due to the mass. This is called inertia force. Inertia force. That's why you may have observed that if the building is only what is called only 1 story or 2 story building, we barely go for structure dynamics, what we call earthquake analysis for such buildings, because we know the mass of this building is much less, isn't it? Mass of the building is much less. That's why we don't go for what is called earthquake analysis of small buildings, let's say 1 story or 2 story building. Okay, but always earthquake analysis performed for higher story building, and if the mass is more, then as the equation itself suggests, plus ku equal to p. Here this is the additional force that is causing, and we in structure dynamics we deal with this force. This is the force which has opened the field of structure dynamics to take care of about this force. More the mass, more will be the force generated due to the system. Now as I have said, first we will try to simply solve this. We'll try to simply solve this mass spring damper system. So let us write the equation here. M, this is u, m u double dot plus k u equal to 0. Initially we are considering the free vibration. Free vibration, that is, there is no force acting on it, like there is no earthquake force or there is no external force acting on it. So this is a free vibration. Now how do you define free vibration? Let's say you have a pendulum or you have a steel ball and just tied with a rod. How to do free vibration? Simply you just give one pull, you just pull it here and you leave it, so it will vibrate like this. If there is a damping, it will go down, or if there is no damping, it will keep on vibrating for an infinite time. So this is called free vibration. That means you say, no, why I have applied initial force, as you are saying free vibration, there is no force. So this is free vibration. You are not keeping your force continuously. When it is force vibration, that means what happens? When there is a force vibration, the difference between free and force vibration means I have pulled this and I kept on applying the force. I keep on applying the force. I'm applying the force. Like I have first is I have pulled on this side, then again I have pulled on the other side, like that. So my force is continuously present in the system. But in free vibration, I have simply given initial displacement or initial velocity. That means I have simply pulled it and I have left it. I'm not here. I have just simply left the pendulum. So it will keep on vibrating like this, and it will, if there is a damping, it will come to its original position, or it will keep on vibrating throughout the life. So to solve this equation of motion, what we do? Simply you can assume the solution for this. Let us assume let us assume that here this u, sorry, it is not writing, u of t, actually this is a variable of t, I have forgotten to write, u of t equal to e to the power st. Okay, I have simply assumed a solution. Now put this value, so u dot t will be as e to the power st, and u double dot t will be s square e to the power st. You will get this solution in any book, any structural dynamics books. I am just performing it now. So if I put these values back to this equation, what is happening? M s square e to the power st plus e to the power st I am putting back in this equation equal to 0. Now if I take the common, e to the power st common, then here we are missing k, e to the power st common, then it becomes m s square plus k. This is my final equation. Now for non-trivial solution, we know that e to the power st cannot be 0. So what will be the 0? M s square plus k equal to 0. So if I solve this equation, s square equal to minus k upon m. So s will become square root minus k upon m, and we know that I equal to minus 1. If you know I equal to square root minus 1, so if I simply write this, then it becomes s equal to I, it will be plus minus because we are omitting a square, plus minus k by m. Now for linearly differential equations, LDE, we have constant coefficients, so the solution will be again, I can write that initially we have assumed u of t equal to e to the power st, so the solution that we have got is a1 e to the power I omega n t. Now why omega n? Because k upon m we can write I into omega n. Omega n equal to square root k by m. So I omega n t plus a2 e to the power minus I omega n t. Now these things, if you simply solve, you know that initial displacement u of 0 will be 0. Okay, initial boundary conditions if you simply apply, and initial velocity will be 0. If you simply put this, you put the u of 2 equal to 0 from here at time t equal to 0, so here you can find out both a1 and a2. So finally you will be getting an equation called u of t equal to u of nod cos omega n t plus u dot nod omega n sine omega n t. So this is the final equation of motion we'll be getting for this. Okay, this is the final equation of motion we'll be getting for this. Now what is u dot? U dot is the initial displacement, u dot 0 is the initial displacement, and u of 0 is initial displacement, u dot 0 is initial velocity, omega n is damping, omega n is the frequency. And if I write everything clearly, then what we had a equation, system of equation m u of t double dot plus k u of t equal to 0. There is no external force, and we have got the solution of this, where omega n is my square root k by m. Okay, so these two things we have got. So I'm not going deep into the solution and etc., because that will unnecessarily lengthen the video. So what I think is, from next time onwards I'll take two separate classes, where in one hand I'll explain the structure dynamics, and on other hand I'll solve those problems in MATLAB, because these combined will create a problem. Because see, those who are only here for learning MATLAB, they'll not be benefited for all this solution and stuff. So I'll solve this equation in this first class, and from next class I'll separate this structure dynamics, and the same problem will solve in MATLAB in a separate class. So that will be helpful. Now we'll try to make this code in MATLAB. So let us first quit everything. I'll write u of t equal to, okay, everything I'll use capital letters. U of t equal to u of 0 star cos give bracket cos omega n t cos omega n star t, then plus give a bracket here u dot 0 upon omega n. Make sure when I'm writing everything is there, you should not match capital letter and small letter. Omega n and then star sine sine omega n and star t. Star means multiplication. Now we have written the total equation. What I'll do before that, see, if I try to execute now, software will tell me that there is no such variables, isn't it? We have not assigned u dot 0, cos we have we know, software knows omega and t, so we'll try to assign one by one. So u of 0, let us take a problem where initial velocity was 2, okay, 2 meter per second. Okay, I'll write a comment, initial displacement to 2 meter and u dot 0. I'll simply copy this. U dot 0 is let's say 0.1. So what will it will be? Initial velocity. It will be 0.1 meter per second. And these two are required, and we just have to find out omega n. Wn equal to, we know, sqrt square root k by m. Now k is the system stiffness, you have to define, and just mass of the stiffness. So system stiffness, let's say 156. So I'm taking random value, and stiffness force required to cause unit displacement. So let's say this is in Newton per meter. This is in Newton per meter. Okay, I'll use comment option and I'll suppress this, and mass, let's say 10 kg. Always keep SI units, 10 kg mass, and this is stiffness. Okay, so now all the values are defined. If I try to solve, we'll get, but the thing is that here one thing is missing, t. Now t, for how much time you want to see. So these problem we want to see it for 10 seconds. Let's say this you have been given this setup where is a mass is attached to a spring, and what you do, you have simply pulled this mass upward and left it. Simply you have given little bit of displacement and you leave it. So what will happen, it will vibrate like this, it will go up. Once you have pulled up, it will go up, then again it will come down, go up, come down, like this. So you have been asked to monitor the response for 10 seconds. So t equal to 10 seconds. So how the response will be monitored? Let's say t equal to 10 seconds. Now to track the history at t equal to exact 10 second, where it will be, you can simply find out, like after 10 second where it will be or what will be the response, you can find out. But you have been asked to monitor the response each 1 second. In 1 second, what is the response? That means we'll divide 10 second in 1 second, 0, 1, 2, 3, 4, 7. So likewise we'll plot the history. So again we'll use for loop for t equal to 0 to 10 and give an end loop, and here in bracket simply give t. So it will note down the response. Now run the, so there is a problem, indices must be positive integers or logical values. So okay, this one will be 1 to t, sorry. Okay, we'll track from 0 to 10. Again, here one thing that will come into play. Here I have used this condition. This one I have explained you earlier. Okay, so this condition will play. If I write I equal to 0, I equal to 0, and here I'll write I. Now why, if I try to execute, it will give me the same error. Why? Because see here, if I pause the program, here I is 0. That means this is a vector. So you cannot write a vector like vector has to be some dimension, right? If a is a vector, then it has some dimension like 1, 2, some values. It cannot be 0. If it is 0, means value can be 0, no problem. But here a of 0 means there is nothing in the system, so it cannot be a 0. It has to be a of 1. Then only, that means there is only one element in the model. If a of 2, that means it will have 2 element in the vector. So that's why it is giving me that error. One more thing, whenever you are facing in MATLAB, whenever facing your such error, simply copy this error and paste in Google. You'll get all the problems that you have. Now if I show you, here I equal to 0, but I need I equal to 1. So what I'll do, I'll write I equal to I plus 1. This is a very strong logic which we can use in many a times. Now you see, again if I run it, you will not see I equal to 0, it will become 1. So each leap it will keep on increasing. So if I simply run it, we have got a history of u of t. Okay, now let us try to plot u of t. plot, plot u of t. Now if I simply again try to run it, it will give me the plot of u of t. So this is how, you see, we should have got the response of in the form of sinusoidal curve like this. Okay, but here we are not getting. Why? The reason lies over here. See, as I have said, omega n is the frequency. Again, let us go to the definition of frequency. It says 12 cycles in 1 second. Sorry, 12 radian per second. Omega n is nothing but my radian per second. It is radian per second. This is my what is called angular frequency. Okay, this is my angular frequency. So this is radian per second. Now in 1 second it is going 12 radian, isn't it? 12 radian in 1 second, it is going 12 radian. Now if I want to get my what is called cycle per second, okay, I have to convert in cycle per second to know that how many second is required to get 1 cycle. See, here it has not performed 1 cycle, it has simply going down. Now if I increase the time period to 100, you'll see a different scenario. It is increasing, and here I have made it 100, but here I have not increased it. Sorry, it will not be 100. Okay, I'm checking it for 100 seconds. So see, in 100 seconds it has not completed one complete cycle. It has just completed, I would say, 90 degree, or I would say, if I have to give the example for this, what it has done is, try to understand. what is happening over here. I have given an initial displacement, it has gone up, and it has simply gone up, and it did not come back, it is yet to come back. So this represents only it has gone up. Okay, now if I increase it to 1000 time period, I am taking it for checking it for 1000 seconds, you will see that yes, now see it is going up and down, up and down, up and down. So what happens now? I need to find out the time period, like in 1 second how many cycles it can perform, what is the time period. Okay, so we know that, so the frequency in cycles per second, we want in cycles, because this one you have got, this is cycle, this is, if you see, starting from this here, one cycle is getting completed. If I keep my velocity 0, then I'll get better visualization. Okay, let us keep the velocity 0, let us check. Okay, and initial displacement is also 0, there will not be any response. Let us keep some value, no problem. Okay, now see, I have to find out the frequency, that is in cycles per second. So I'll write Fn in cycles per second, it will be 2 pi upon omega n. So this will give me the frequency in cycles per second. So what is the frequency in cycles per second? Fn, the value of Fn equal to 0.5, that means 0.5 cycles in 1 second. So this is very less. Now to make you understand, what I'll do, I'll trick some data. Okay, so little mistake I have done, that Fn, it is not 2 pi upon omega, it is omega upon omega n upon 2 pi. So from there, if you see this, the here the Fn value, that is the cyclic frequency is 1.99 cycles per second, nearly 2 cycles in 1 second. Okay, nearly 2 cycles, it shows Fn equal to 1.99, 2 cycles in 1 second. If you see time period required for 1 cycle is 0.5 second. So if you see, for 1 cycle it is 0.5 second, and in 1 second it is simulating 2 cycles. So if I simulate it for 1 second, so 2 cycles in 1 second. Now if I run this code, you see 2 cycle. What is the definition of frequency? I have told you that you have started from your home, from this point. If I expand this, you have started your home from your home, let's say this is your home, you have started, and this is your college. Okay, now this is your college, sorry, this portion is your college, this portion is your college, and this is home. So you have started from your home, you have come to your college, then again you have come to your home. So 1 cycle, again you have started from your home, you have gone to your college, you have reached to your home again. So this is 2 cycles. Now how much time it is required to perform 2 cycles? See, 1 second. And frequency, again you see 2 cycles in 1 second, 2 cycles in 1 second. That means how much time it will be required to perform 1 cycle? It will be 0.5 second. If you see, if I run this, you will see that 0.5 second was required to perform 1 cycle. So this was a basic coding session, I mean MATLAB. So this will be helpful for you initially, because here you learn lots of things. You just practice this code. If you have any doubt, any query, I'll I'll, I'll not go deeper in this code uh, anymore. From next class onwards, I'll keep two separate session. One is for dynamic analysis, one is for MATLAB code. Now, one thing you can here simply the graph that you have plotted, you can rename, you can name the axis of the graph. You can simply name the axis of the graph like x level, y level, or you can change the color of this graph. So if I give a comma and give a quotation, single quotation, and let's say I write y, so what it will happen is it will give me the graph in yellow color. If I make it, sorry, if I make it red, it will give me in red color, and if I make it red dot, then it will give me dotted line. Dotted line, see, dotted dots are, three dots are there. So if this is a long curve, you will be able to visible more things. If I give a dash, then dash dash will be there, dash dash will be there, sorry, dash dot, dash dot, see, dash dot, dash dot. So these things you can vary. I'll show more things about this, like how to give x level, y level. You can add those things also. So you have seen this. Now if I have to add a title of the graph, so what I'll do it, I'll simply write title and the name of the graph. So you see title, simply write title, and the name I'm writing is graph, or I can write free vibration graph. You have to write in comma and quotation. If I run this, see, name has come, free vibration. Now I have to name the x level and y level. There's the x and y axis, so I'll simply write x level. X level is my time, so x level has come as time, see, bottom. And again, if I need y level is my amplitude. So likewise, this is the graph plot, and you can use legends also. So we'll see in next consequences classes, next subsequent classes, how to give many more things. So this is how we can write. So this is the free vibration problem. Now let us talk about deal about the graph little bit. Talk about the graph little bit to understand this graph in a structured dynamic way. So what I'll do, I'll take little fine step. So I'll get a smooth curve. Okay. Now if you see, what is the difference between these graph, and I'll copy the same thing. I'll copy the same thing again, and or I'll again add a for loop. Better, let us actually what I want to do, I want to compare two different velocities. Okay, so what I'll do, I'll again add a for loop. I'll again add a for loop for just give a random value 1 to 2. Just I want to compare two different values, give a and this plot let's say velocity, name it, I give two velocities, make a matrix of two velocities. Let's say one is 0.1 and one is 0.8. okay, Now this is a matrix that I have created. Now if I simply, instead of directly taking the velocity, if I tell the software take velocity equal to yy, so what will happen? First yy value will be 1 when the loop will run, then velocity, it will be 1 over here, so it will take this value, and in second loop this y will be 2, so velocity it will consider this. So for that I'll simply use the hold on option. Hold on, and I just try to plot what is happening. So see, we see there is two graph, and what I'll do one more thing. I'll not mark any color over here, so it will give me two different distinct color. Sorry, I have to remove this. Okay, it is giving me two different graph. So what I'll do, I'll change the velocity a little bit higher so you can see the difference. Okay, now see what is happening. This one, the blue color, you see this one is for velocity 0.1, and this what you call yellow color or brown color, whatever, it has velocity 8. So when the velocity is increasing, the initial slope from where it is start, it is changing. So the velocity, when the velocity was 8, the curve, how the curve has started, if you see, if you try to understand how the curve has started, the curve has started something like this, isn't it? And when the velocity was less, 0.1, it is starting like this. Now you will see when the velocity is 0, what will happen? Let us make the velocity 0. Let us make the first velocity 0. Now if I show you the velocity matrix, this is how the velocity matrix looks like: 0.1 and 0. So 2 column, 1 row. Now here the velocity is, I am assigned as a variable. So when this is 1, that is yy will be 1, that means velocity will be considered 0, and when y will be 2, the velocity will be considered 8. So if I run it again, you will see two different behavior of the graph. See, if I show you this, see, this is this portion. If you see, one is going up, that is the velocity was 8 for brown color or what you call, and for green color, if you see, or blue color, I have this color blindness, it is coming directly down. So what is happening, when the velocity is 0, it is coming directly like this. Sorry, it is coming directly like this. Okay, when the velocity is not 0, it is going like this. Now let us do the reverse thing. Now what we will do, we will keep initial displacement 0. Now change this matrix to displacement, I'll write displace, and initially I'll keep the displacement 0, then I'll keep a displacement of 2, which is over here. Velocity, let us keep the velocity as 8. I have now made the velocity constant, and to vary the displacement, what I'll do, I'll write displacement, and in bracket I'll give yy. So what is happening over here? Just pay attention. What is happening? Initially it will take 0, then the velocity displacement will be 2, but velocity is constant. So what will happen? Let us plot this. So now when the displacement is 0, see, it is starting from this point, directly from 0, amplitude is 0, and when the displacement is 2, it is starting from this point. But if you see, both the curve is having same slope at the point, because velocity is constant. Here velocity is constant, but displacement is changing. Okay, so that's all about, that's what I just wanted to explain you. And if I run it for 1 second, you'll see there is two cycles will be clearly visible. See, 2 cycles. If I keep 0 only and I want to run only 1 second, for 1 second, see, what is the time period? 0.2, yeah, 0.5. So see how much time is required to complete 1 cycle. 1 cycle is getting completed in near about 0.5 second, which is here visible, 0.5 second, and second cycle is also getting completed over here. So there are 2 cycles. So this is how system is vibrating. And if you want to take the velocity and acceleration, so you'll have to take the derivative of this 110 u dot I, and if you want to take the acceleration, you can take derivative twice that u dot ti, u dot ti and u double dot ti. So you'll get the velocity and acceleration. So that's all. Thank you for watching this video, and please don't forget to subscribe my channel and share this video.